Hello folks, welcome to today's video. In today's video, as you can see, we're going to talk about the surface area of composite objects. So in the previous video, we talked about the surface area of simple objects. And what I mean by simple objects are objects that we can name, right? So a cylinder, a rectangular prism, a triangular prism, right? We can find the surface area of these simple objects just by considering the faces and the bases. And we can even describe them using formulas, right? Once we get comfortable enough with them, we could even assign formulas to them, and we can just do it the same way every single time. But what we find is that we don't always have simple objects. Sometimes we have these things that we call composite objects. And what a composite object is, it is two or more simple objects put together, right? So if I had, for example, a large rectangular prism, and then on top of that I had a cylinder, right, and I were to put them together, there's no one formula that can help us find the surface area of that thing. We have to use what we already know about their simple objects and then try to derive what the surface area is going to be. So in my mind, there's two strategies here. Strategy number one is kind of what you see on the screen here. So first thing that we do is we find the total surface area of all objects. We say, okay, well, if I have a rectangular prism and I have a cylinder, let's pretend that those two objects are separate from one another and find each of their surface areas. Okay, so then once we've done that, we're going to find the area of the hidden faces. And what I mean by that is when that cylinder and that rectangular prism come together, where they touch, we don't want to have that as a part of our final answer because those faces are hidden, right? It's not something that we can add in as our surface area. So what we're going to do is we're going to find the area of those hidden faces. Then finally, once we know those two numbers, once we know the surface area of the two objects and the surface area that we can't see, we're going to subtract those two numbers from each other. Okay, so let's take a look at that. So here I have three rectangular prisms kind of stacked together to make what looks like maybe a step, right? It almost looks like a stair. So if I were to take these three rectangular prisms and pull them apart, so if I had 1, 2, 3, right? Rectangular prism 1, rectangular prism 2, rectangular prism 3. So if I wanted to find the surface area of rectangular prism 1, I would do that just in the same way as the simple object we talked about in the last video. So this is a 3 by 3 by 9 rectangular prism. So I'd find the area of the two bases. So there's two of them. So it's going to be 2 times 3 times 3 plus, and then we have a face here that is 2 times 9 times 3, and that could be the top and the bottom of my rectangular prism, plus 2 times 9 times 3 would be the front and the back of my rectangular prism. So then if I were to do that and add them all up, so 2 times 3 times 3 plus 2 times 9 times 3 plus 2 times 9 times 3, we get 126 centimeters squared. And then if I were to do the same thing for rectangular prism number 2, what we see is that the dimensions are the same. It's a 3 by 3 by 9, right? So we would get 126 centimeters squared, and then the same thing would be true for rectangular prism 3. It'd be 126 centimeters squared. So what that means is that the total surface area of these three rectangular prisms would be 3 times 126, or 378 centimeters squared. Now, this picture, this composite object, is not three separate rectangular prisms. It's them, but stacked together. So now what we need to do is find all of the hidden faces. So anywhere where one prism touches another, right? So right here and right here, right, we have two prisms coming together. So what we need to do is we need to find the area of those hidden faces. So from prism number 1, we have a rectangle that is touching a rectangle from prism number 2. So there's actually two rectangles that are being covered. So if I wanted to find the area of that hidden face, it would be 2 times the area of those rectangles. So 3 times 9, right? And that's 54 centimeters squared. And then again, for this one down here, for prisms 3 and 2, again, they have two rectangles that are coming together, one from prism 3 and one from prism 2. So again, it's 2 times the dimensions, or the area of those rectangles, so 2 times 3 times 9. So what that means is that the surface area, my final answer, is going to be the 378, right? The three rectangular prisms all added together, minus the hidden faces. So minus 54 minus 54. So that's 270 centimeters squared. And that 270 centimeters squared is my final answer. That is the area of all my objects that I can see, subtracted by any hidden faces. Okay? So as I mentioned at the beginning, there are actually two strategies. So strategy one is what we just did, find total surface area, then subtract any hidden faces. Strategy number two is a little different. And I find strategy number two, if you have a good kind of spatial awareness, it might be a little easier. But if I were to look at this shape just as a rectangle, just the front of it, right? Even though there's an object sitting here, sticking out from it, if I were to just look at it direct on, it would still just look like a rectangle, where the part of it that's being covered by the back here is then just replaced by this front. So what that means is that to look at this thing, I would just have to find the area of that rectangle, right? So then now let's do that, right? So then I would look at the area of my front rectangle here and my back rectangle, right? Because they're that pair, which is 7 by 5, so it's 2 times 7 times 5, right? And then I could add to that the two sides, which are 5 times 5, and then the top and the bottom, which again is 7 by 5. Okay, so now all the sides that I've done are the top, the side, the bottom, this side, and then this side here, right? So now the only thing that I haven't calculated, if I were to turn my rectangle and look at it directly sideways, right, I would see this square that is 5 by 5, but I would also see this square here that is 2 by 2. And there's another square on the other side that is also 2 by 2, so 2 times 2 times 2. And then if I were to look at it from the top, I would see this rectangle up here that is 7 by 5, and one at the bottom that is 7 by 5, but also sticking out from that, I would see a second rectangle that is 2 by 2 and 2 by 2. So now, if I were to add all these together, this should give me my total surface area. So 2 times 7 times 5 plus 2 times 5 times 5 plus 2 times 7 times 5 plus 2 times 2 times 2 plus 2 times 2 times 2 is 206 centimeters squared. So this strategy I like to call 6 faces. Okay, so instead of breaking my objects up into their simple composite objects, what I do is I break it up into the 6 directions that I can look at it from, right? I can look at it from top, bottom, left, right, front, back. And each of those directions that I'm looking at it from, I'm going to consider the two-dimensional picture that I'm seeing, right? So for this thing, when I look at it from the front, all I see is a rectangle that is 7 by 5. And when I look at it from the back, all I see is that second rectangle that's 7 by 5. Right? When I look at it from the side, I see a square that is 5 by 5, but I also see a second square that is 2 by 2. And when I look at it from the other side, when I look at it from this side over here, I see the same thing. And when I look at it from the top, I see a rectangle that is 7 by 5 and a square that is 2 by 2. And when I look at it from the bottom, I see a rectangle that's 7 by 5 and a square that's 2 by 2. So that's where all of these calculations come from. And when I add those all up, I'll get my total surface area. Okay? So again, it's kind of up to you which strategy makes the most sense. And I would never say one strategy is better than the other. Everyone's brains work a little differently. We all see the world in a slightly different way. So if that's the case, then you need to decide for yourself what makes the most sense. Now, depending on the object, that could change, because the problem with something like doing the 6 faces is, what does a cylinder look like, right? It doesn't really have that faces. So when we start adding cylinders to it, we might want to be careful about how we do this. And we can even kind of mix and match these two strategies, right? So if I think about the 6 faces for a second, okay, and I just look at it from the right here, what will I see, right? I'll see a rectangle that's 3 by 5, right? Because yes, there's a circle here, but if I'm looking at it just as 2 dimensions, that circle is inside that rectangle. So it's still just going to look like a rectangle, right? If I couldn't see the edges of the circle, it's still just going to look like a rectangle. Right? So if I wanted to do the area like that, I could. Now, let's go back to the first strategy just so we see it again. So I'm looking for the area of my two composite objects. So I have the area of my prism, right? So that's my rectangular prism here. So it's those pairs of sides. So it's 2 times 3 times 5 plus 2 times 3 times 11 plus 2 times 5 times 11, right? That's the area of my rectangular prism. 2 times 3 times 5 plus 2 times 3 times 11 plus 2 times 3, sorry, 2 times, 2 times 3 times 5 plus 2 times 3 times 11 plus 2 times 5 times 11, and we get 206 centimeters squared. Right, so that's my prism. And then if I want to do the area of my cylinder, so that's the area of my top and my bottom circles, right? So 2 pi r squared plus 2 pi r, we know r and h, sorry, okay, so if I want to find the area of my cylinder, right, we need to find the area of the top and the bottom circles. So that's 2, because there's 2 of them, times pi, r in this case is half the diameter, so 1.5 squared, plus 2 pi r h. Right, so 2 times pi times 1.5 squared plus 2 times pi times 1.5 times 5, and we get 61.3 centimeters squared. So what that means is the total surface area of these simple objects is 206 plus 61.3, and that's 267.3 centimeters squared. Now we need to find the area of the hidden faces. So the hidden faces here are where these two circles touch, right? So this circle from my cylinder is covering a circle from my base of my prism, right? So there's going to be, the area of the hidden faces will be 2 times pi r squared. Right? So 2 times pi r squared is 14.1. So what that means is that my total, my final answer, my surface area is going to be 267.3 minus 14.1. And that is 253.2 centimeters squared. Okay. So that is it. That is our composite objects, right? So again, a composite object is multiple simple objects coming together. And I find it hard to say, do it this way or do it that way, because especially with this unit, there are so many ways to kind of perceive these objects, to look at these objects, that it takes a lot of practice and is something that you can develop for yourselves. Again, this video went a little long today, but I wanted to try to get through it so that we would have it and be done. All right, so that is it for surface area. I will see you all in the next video.